Hey everybody, wanted to make sure I went through the homework and really solved it carefully. So this is kind of our first set of written homework problems for the year. We're going to use this value for g. We're going to be paying attention to sig figs. So if you notice on this, we've got 3 sig figs here, 3 sig figs here. We have a ball rolling down a slope. It's got an acceleration, and we want to know the time it takes to reach the bottom of the slope and the ball's final velocity. So what I'm first going to do is I'm going to go into the data booklet and get the equations that we need, which are going to be v squared is u squared plus 2as, v equals at plus u, and s is ut plus 1/2 at squared. And so let's just kind of label the variables that we have. We know that s is 445. We know that the acceleration is, and you know what, 445 meters, you know that a is 3.16 meters per second. We do not know the time. We know that the initial velocity is 0. And we don't know the final velocity. So those are the letters that we have. So let's just go ahead and begin with the things that we can work with. So I'll actually start with this top equation here. We have v squared is u squared plus 2as. So v at the bottom of the hill, we start off with a speed of 0, or velocity of 0. We have our 2, which is given in the problem, 3.16 times 445, and so we can actually go ahead and solve for v using that set of numbers. And when we do that, we will end up getting 2 times 3.16 times 445. We'll square root that, and we're going to end up getting v is 53.06, and I want to round that carefully, okay? So I should actually write this as v is 53.1 meters per second to keep the sig figs correct, since we have 3 here and 3 here. And then the time it takes, a couple ways we can do this. I could recycle the formula. In fact, I think I will go ahead and do that now. V is at plus v naught. Plus v is at plus u. So that's going to be 53.1 equals 3.16 times t plus 0. And so the time to hit the bottom works out to 16.8 seconds. So that's question number 1. And we'll actually do this one problem at a time.